Hello everyone, welcome to the series on chapter 1 of CBSE class 11th maths sets. This video is about the exercise 1.1 problem solutions. We'll solve every 6 problems in that exercise. My name is Tejesh Kaliki from 2 Academy. Now let's get started. So first, let us start with the first problem. Which of the following are sets and you need to justify your answer. For this problem, the concept you will use is that a set is a well-defined collection of objects. Here, well-defined means that the set does not vary from person to person. So by using this, let's try to solve these problems. So here the first one is the collection of all months of a year beginning with the letter J. So what are the months that start with the letter J? They are clearly January, June and July, right? So these three are the months in the year starting with the letter J. So here, no matter who you ask, they will give the same 3 months as the result. So therefore, it means that this does not vary from person to person, which means that it is well defined and hence it is a set. So this is how you need to solve these problems. You just need to read the question and need to find whether it is well defined or not. Here it does not vary from person to person, so therefore it is well defined and hence it is a set. Now the second one, the collection of 10 most talented writers in India. Here the keyword is most talented writers. So if you ask this same question for 3 different people, will all 3 of them give the same answer? Obviously not, right? Everyone have their opinion of who is the best writer. So therefore this will be different for every person, which means that it is not well defined. And hence this is not a set. And now the third one, a team of 11 best cricket batsmen of the world. So once again, here the keyword is best. Now if you ask 3 different people who are the 11 best cricket batsmen in the world, will all 3 of them give the same answer? No, right? Every one of them will give different answer. So same as before, this is also not well defined and hence it is not a set. And now the fourth question, the collection of all boys in your class. So if you take your class, there will be some number of boys in your class, right? So here the collection of all boys in your class. Now if you ask these 3 different people, so you will tell the boys in your class and some other person will also tell the boys in your class itself, and the third person will also tell the boys in your class. So no matter who they are, your class is the same and the number of boys in that is also the same. So therefore this will be same for everyone. So it does not vary, which means it is well defined and hence this is a set. So here the first one, the months that starting with the letter J are January, June and July, which are same for everyone. So therefore it is well defined and hence a set. And the second one and third one are different for everyone. So therefore they are not well defined and not a set. And similarly the final one is same for everyone. So therefore it is well defined and hence it is a set. There are 5 more problems in this question. Let's try to solve them. The collection of all natural numbers less than 100. So everyone knows that natural numbers start with the number 1, 2, 3 and here since it is less than 100, it goes on until 99. Now this will be same for everyone, right? No matter who they are, the natural numbers less than 100 will be 1, 2, 3 and so on until 99. So therefore you can say that this is also well defined and hence it is a set. And now the sixth one, a collection of the novels written by the writer Munshi Premchand. So here, for example, if you go to a library and ask what are the novels written by this writer, then the collection of the novels will be the same, right? No matter who you are, if you go to the library and check the novels of this writer, they will be the same number of books. So therefore, this is same for everyone and hence it is well defined and hence it is a set. And now the seventh question, the collection of all even integers. So even integers means first you have the positive integers which are 0, 2, 4 and so on. These are all even integers. And similarly you can take negative as well, -2, -4 and so on. So all of these combined will be the even integers. Now if you ask the same question many different people, will the answer change for everyone? No, right? No matter who you are, the even integers are the same. So therefore, this is also well defined and hence it is a set. And now the eighth one, the collection of questions in this chapter. So here in this chapter in exercise 1.1 we have a total of 6 questions, and then we have the exercise 1.2 with some questions and so on. But no matter who checks this textbook, the number of questions in each exercise will be the same, right? So therefore the collection of the questions will be the same for everyone. So therefore this is also well defined and hence it is a set. And now the final one, the collection of the most dangerous animals of the world. So here once again the keyword is most. When you have words such as most, best, etc., in most of the cases it is not a set. So even here, what are the most dangerous animals in the world? Some people will say tiger is one of them, and some people can say lion, and some people might even be afraid of dogs. So therefore, there is no clear definition of what the most dangerous animals are, right? So this will be different for everyone, so therefore it is not a set. I think you now have a clear idea of how to solve problems such as this, right? You just have to read the question and find whether it is well defined or not. If it is well defined, it is a set. If it is not well defined, then it is not a set. So now let's move on to the second question of the exercise. So in the second one, let capital A be the set of 1, 2, 3, 4, 5 and 6. Then insert the appropriate symbol belongs to or does not belongs to in the blank spaces. These are the symbols that mean belongs to and does not belongs to. What they mean is that if small a is an element of the set capital A, then you will write small a belongs to capital A. That is, small a is an element of the set capital A. And similarly, if some element small b is not an element of set capital A, then you will write small b does not belongs to capital A. So if it is an element, then you will write belongs to. If it is not an element, then does not belongs to. So let's see for our given problem. So first one we have 5 dash a. So here is 5 in the set, 5 is in the set, right? So therefore you will say 5 belongs to capital A. And then we have 8. Is 8 inside this set? No, right? There are only elements from 1 to 6. So therefore there is no 8 in this. So therefore you will say 8 does not belongs to capital A. And similarly 0. 0 is also not in the set, right? The numbers start with 1. So therefore 0 also does not belongs to capital A. And then we have 4. 4 is clearly in the set. So therefore you will say 4 belongs to capital A. And similarly we have 2. 2 is also in the set. So therefore 2 belongs to capital A. And finally 10. 10 is not in the set, right? So therefore 10 does not belongs to capital A. So this is how you need to find whether an element is in the set or not. If it is in the set, you'll write belongs to, and if it is not in the set, you'll write does not belongs to. Now let us move on to the third problem of this exercise. Write the following sets in the roster form. So first, let's see what the roster form is. So in the roster form, you will list the elements of the set separated by commas and enclosed in curly braces. So let us try to solve for this problem. So first of all, we have capital A is equal to the set of all x such that x is an integer and minus 3 less than or equal to x less than 7. So here x is an integer and minus 3 less than or equal to x. So therefore the elements in the set start with minus 3, and since it is less than 7, they will end with the number 6. So in the middle we have minus 2, minus 1, 0, 1, 2, 3, 4, 5 and finally 6. So here we have listed the elements in the set, and now we have to separate them by commas, and clearly we separated them with commas as well, and finally we have to enclose them in curly braces. So this is our set capital A in the roster form. So this is the solution of our problem. Now the second one, capital B is equal to the set of all x such that x is a natural number less than 6. So clearly natural numbers start with 1, and then we have 2, 3, 4, and since it is less than 6, we have to end with 5, right? 5 is the last number that is less than 6. So we have listed the elements and now separate them with commas and enclose them in curly braces, and this gives our set capital B. So this is the roster form representation of set capital B. Now the third one, capital C is equal to the set of all x such that x is a 2-digit natural number such that the sum of its digits is 8. So since it is 2-digit number, it will have 2 digits clearly. And let's say the first digit is 1, then what will be the second digit? 1 plus 7 is equal to 8, right? So therefore the second digit must be 7. So therefore 17 is one such element, that is a 2-digit natural number with sum of its digits as 8. But after that, let's say the first digit is 2, then what will be the second digit? 2 plus 6 is equal to 8, right? So therefore the next digit must be 6. So therefore we have 26. And similarly, if the first digit is 3, the next digit must be 5. 3 plus 5 is 8. And then we have 44. 4 plus 4 is also 8. And then 53, 62, 71, and 80. These are all the numbers that are 2-digit natural numbers and the sum of the digits is 8. So now you have to enclose them in curly braces, and this is our set capital C in the roster form. I think you get an idea on how to represent sets in roster form, right? First you will just list the elements in the set and then you will separate them by commas and finally enclose in curly braces. Note that when you are answering this question in the exam, then first write some steps such as first the elements in the set or unlist all the elements and then write in the roster form because it will be better for presentation purpose. Now let us try to solve 3 more problems in this question. So here when solving these 3 problems, you need to remember an extra point in the roster form. That is, the elements in the set must be unique. That is, you can't write the same element multiple times. So here we have capital D is equal to the set of all x such that x is a prime number which is a divisor of 60. So we need to find the prime divisors of the number 60. So first you can divide this by the prime number 2 which gives us 30, and finally again dividing by 2 you get 15 which is nothing but 3 into 5. So therefore you can write 60 as 2 squared into 3 into 5. So here when listing that, the prime numbers are 2, 3 and 5, right? But you might ask, here it is divisible by 2 twice, then why did we only write once? That is because, as we have said, the elements in the set must be unique. So that's why we only write 2 once. And this is our set capital D in the roster form. And then we have capital E is equal to the set of all letters in the word trigonometry. So here we have to list the letters in this word. So starting with T, and then we have R, I, G, O, N. But here comes a twist. Here the next letter is O, right? And O is already written once. So therefore you should not write that again, because once again, as we have said, the elements in the set must be unique. So you won't write O. And then we have the letter M. So therefore you will write M and then E. And then once again we have the letter T which is repeated, so you won't write that. And finally R is also repeated, so you won't write that, and you'll end with the letter Y. So all of these combined is our set capital E in the roster form. It's clear, right? You have to list the elements separated by commas enclosed in curly braces. And finally we have capital F, which is the set of all letters in the word better. So once again, inside the curly braces you list the letters in this. We have B, E, T, but the second T is repeated, so therefore you won't write the repeated letters. And then E is also repeated, so you won't write that. And finally you have the letter R. So therefore all of this combined is the set capital F. So this is the third problem. Now let's move on to the fourth problem in this exercise. Now the fourth problem, write the following sets in the set builder form. So in the set builder form, how you will denote a set is you will use curly braces to denote it is a set, and then you will use a generic element x followed by colon which is read as such that, and finally the property satisfied by the elements of the set. So let us start with the first problem here. We have the set of 3, 6, 9, 12. Now can you notice what they are? They are multiples of 3, right? So clearly the first number is 3 into 1, the second number is 3 into 2, and then 3 into 3, and then 3 into 4. So it is 3 times a natural number, right? So when writing this in the set builder form, you will write this is equal to the set of all x. X is a generic element such that since it is multiple of 3, you can write x is equal to 3n, where here clearly n is a natural number, right? the set of all natural numbers is denoted by capital N. So capital N is the set of all natural numbers. So you can say small n belongs to capital N. It is a natural number. And finally, here we only have the first 4 multiples, that is until 3 into 4. So therefore, you can say n less than 5, right? So this is the set builder form representation of the set. The set of all x such that x is equal to 3n, a multiple of 3, where n is a natural number, and finally n is less than 5 because we only need the first 4. Now let's see the second one. We have 2, 4, 8, 16 and 32. Clearly these are all powers of 2, right? So we have 2 power 1 which is 2, and then 2 squared which is 4, and then 2 cube which is 8, and then 2 power 4 is 16, and 2 power 5 is 32. So when writing this in the set builder form, you will write the set of all x such that x is equal to 2 power n, a power of 2, and then the same as before, where here clearly n is a natural number. So once again you will write n belongs to capital N, and we have the first 5 natural numbers, that is the powers of 2 with respect to the first 5 natural numbers. So you can say n is less than 6, right? You'll get 1 to 5, less than 6 means. So this is the set builder form representation of the set. And now the third one, we have 5, 25, 125 and 625. Clearly these are powers of 5, right? We have 5 power 1, 5 power 2, 5 power 3 and finally 5 to the power of 4. So when writing this in the set builder form, you'll write the set of all x such that x is equal to 5 power n. Before we write 2 power n, here it is 5 power n, where once again n is a natural number and n is less than 5 because we only have the first 4. So you'll say n is less than 5. So this is the set builder form representation of this set. And now the fourth one, we have 2, 4, 6 and so on. Clearly these are even natural numbers, right? So you can write this simply as the set of all x such that x is an even natural number. But you can ask, sir, clearly you can write x such that here even natural numbers means this will be a multiple of 2, right? So x will be 2n. So why can't we write x is equal to 2n where n is a natural number? Why can't we write this? Well, the thing is, this is also the correct answer. So both of these are correct. So you can write any one of these as the answer. And now we have the last one, 1, 4, 9 and so on until 100. These are squares of natural numbers, right? 1 is nothing but 1 squared, and then 4 is nothing but 2 squared, and then we have 3 squared and so on. So when writing this in the set builder form, you'll write this is equal to the set of all x such that x is equal to n squared, where n is a natural number. N belongs to capital N. And clearly here we have the first 10 squares of natural numbers. So you can say and n is less than 11. Or you can also write n is less than or equal to 10. Both of these are the same. So this is the set builder form representation of this. So clearly we are given 5 problems and for each of them we have written the set builder form. I think now you have a clear idea on how to represent sets in the set builder form, right? Now let's move on to the fifth question of this exercise. So the fifth one, list all the elements of the following sets. So in the following sets you have to list the elements in them. The first one is capital A is equal to the set of all x such that x is an odd natural number. So what are the odd natural numbers? They start with 1 followed by 3 which is an odd number, and then 5, 7, 9 and so on until infinity, right? So all of these combined will be the odd natural numbers. So this is our set capital A. So they have asked to list the elements of the set and we have listed the elements 1, 3, 5, 7, 9 and so on, right? And then we have capital B is equal to the set of all x such that x is an integer and minus 1 by 2 less than x less than 9 by 2. So we have minus 1 by 2. How can you write that in the decimal form? 1 by 2 means 0.5 and since it is minus, you'll write minus 0.5, right? And then we have 9 by 2. 9 by 2 means it will be equal to 4. 4 times 2 is 8, 4.5. So therefore, you need to find the integers that are in between minus 0.5 and 4.5. So clearly x is greater than minus 1 by 2. So therefore, you'll start with the number after this, which is clearly 0, followed by 1, 2, 3, and here we have less than 9 by 2, which is 4.5. So you will end with the number 4, right? 4 is less than that. So the last number will be 4. So all of these combined will be our set capital B. We have listed the elements in that 0, 1, 2, 3, and 4. Simple, right? And then we have capital C is equal to the set of all x such that x is an integer and x square is less than or equal to 4. So clearly we need to find the integers such that the squares of them are less than or equal to 4. So first we have 0 squared, which is nothing but 0, which is less than or equal to 4. And then we have 1 squared, which is 1, which is also less than or equal to 4. And clearly minus 1 squared is also 1, which is also less than or equal to 4. And then we have 2 squared, which is 4, less than or equal to 4, clearly. And finally minus 2 squared, which is also 4, which is less than or equal to 4. So all of these are the numbers in our set. So let us try to write them in the order. First we have minus 2, minus 1, 0, 1, and 2. So these are the elements in the set capital C. Now let's move on to the fourth problem in this question. Capital D is equal to the set of all x such that x is a letter in the word loyal. So we have to list the letters in that. First we have L, O, Y, A, and clearly the second L is repeated, right? You should not write repeated letters. The elements in the set must be unique, we have said previously. So therefore, only these are the elements in the set capital D, L, O, Y, A. So this is the list of elements in that. And then we have capital E is equal to the set of all x such that x is a month of the year not having 31 days. So the months in a year are nothing but January, February, March, April, May, June, July, August, September, October, November, and December, right? Now here not having 31 days. So January have 31 days, March also has 31 days, and then May, July, August, October, and December. All these have 31 days in them. So we are left with February, April, June, September, and November. These 5 are the months in the year not having 31 days. So now you have to list them all. So this is the list of elements in the set capital E. We have listed the elements in that. And now we have the final problem in this question. Capital F is equal to the set of all x such that x is a consonant in the English alphabet which precedes K. So here from the starting we have the letter A. A is a vowel. So therefore you want to write that. And then we have B, and then C, D, E is also a vowel. So therefore next we have F, G, H, I is also a vowel, and then we have J. Here we said precedes K, right? So therefore you won't write K. So only these are the consonants which precedes K. So let's list them all. We have B, C, D, F, G, H, and J. So this, all of these combined is the set capital F. So this is how you list the elements in the set when they are given in the set builder form. So let's move on to the problem number 6, which is the last in this exercise. Match each of the set on the left in the roster form with the same set on the right described in set builder form. So these are match the followings. We are given 4 sets in roster form and 4 sets in set builder form. You have to match the corresponding ones. So let us try to solve them one by one. First we have the set of 1, 2, 3 and 6. Let us try to compare this with all the options on the right. The first one is x such that x is a prime number and a divisor of 6. But clearly here we have 6 which is not a prime number. So therefore you can't match both of these. So it's not this. X such that x is an odd natural number less than 10. Once again 6 is not an odd number. So therefore it is not this as well. And then we have the set of all x such that x is a natural number and divisor of 6. So we need to find the divisors of 6. 6 is nothing but 6 into 1 or 2 into 3, right? So the divisors of this will be 1, 2, 3 and 6. Clearly it is the same set. So therefore you can match both of these. And then the second one, the set of 2 and 3. Now here if you compare it with the option B, it is x is an odd natural number, but clearly we have 2 which is not an odd natural number. And now we will compare with the option A, x is a prime number and divisor of 6. Clearly before we have found the divisors of 6 which are nothing but 1, 2, 3 and 6. Now out of these the prime numbers are 2 and 3, right? Clearly this is that set. So both of these are the same sets. And then the third one, the set of MATHEICS. Clearly all of these are letters, right? So you can't match that with odd natural numbers. And the option D is nothing but X, such that X is a letter of the word mathematics. Clearly all of these are the letters in the word mathematics, right? So the third one is option D. And finally we are left with fourth and option B. Clearly these are odd natural numbers, right? 1, 3, 5, 7 and 9. Odd natural numbers less than 10. So this is the solution to this problem. So as you can see, we have solved all the problems in the exercise 1.1 of the CBSE class 11th chapter 1 sets. Thanks for watching the video. If this video is helpful, please like and subscribe to the channel to see more such videos. See you guys in the next video.